Given that the quadratic equation az squared plus bz plus c is equal to 0 has roots alpha, beta, find the sum and the product of the roots. So the roots are the solutions to the quadratic equation. So if alpha and beta are the roots of the quadratic equation, az squared plus bz plus c is equal to 0, then az squared plus bz squared plus c must be equivalent to, if you were finding the roots, you have z is equal to alpha, z is equal to a beta, then you'd work backwards, so you'll get a z minus alpha times z minus beta. If you now expand these brackets, you get z times z minus beta minus alpha times z minus beta, and then you've still got a, so you're going to get z squared minus beta z minus alpha z plus alpha beta. So it's going to give a z squared. This bit here, if you take out a minus sign, will become alpha minus a times alpha plus beta if you take the a in, plus the a times alpha beta. So here now you have the sum of the roots and the product of the roots. So if you now equate that back to the left hand side, we can see that minus alpha plus beta, minus a alpha plus beta must be equal to b. And if we rearrange that, we're going to get that alpha plus beta, the sum of the roots, is going to be minus b over a. And also if we equate a alpha beta to c, c will be equal to a alpha beta, which gives me that alpha beta is equal to c over a. So if we know the sum and the product of the roots, we can actually form the equation that they actually come from by using a different method than sort of working backwards, which we'll explore in future videos. So this is known as the sum of the roots, and this is known as the product of the roots. So alpha plus beta is minus b over a. The product of the roots is alpha beta, which is c over a. I hope this has been a video about the sum and product of the roots of a quadratic. I hope you've understood, and I thank you very much for watching.